Hi everyone, Paul here from Easy Composites. If you're a regular follower of our channel, you'll notice that this video is a bit different. It's not our usual structured tutorial. This is more of an in-depth case study on the build of this carbon fibre downhill bike. This bike was conceived, designed and manufactured from start to finish by the very talented Vlad Yordinov that I've got here with me. He came to us to see whether we were interested in helping him take this design concept through to a finished frame, which of course we were. This was about 2 years ago, wasn't it?
Yeah, that's about right.
A few things excited us about this project. Firstly, bike frame manufacture is one of those questions that we get asked very often, and it'd be a good opportunity to show people just how it's done. And secondly, it's also a fantastic showcase for what can be achieved using the X-Preg out of autoclave pre-preg. You'll have to bear with us a bit through this video. Vlad's a very busy guy and we've been very busy ourselves, so we've had to grab shots of this project as it's going through various phases as and when we could. So you're going to see beards and haircuts come and go, one or two t-shirts come and go. But hopefully, by the end of this video, you'll take away some new knowledge and a big dose of inspiration as to what can be achieved with the right skill and determination, and of course, the right materials and support. So, the finished bike's here.
Yeah, all here, and it took good 300 hours to make it. And this already has been ridden for quite a while and raced. And yeah, we're going to see how actually it was made in the video.
Excellent. Well, okay. Well, clearly this is a piece of art as much as a feat of engineering. So we'll go back to the start and see how it was made. So the first stage of making a mould is making the pattern that the mould's going to be made from. In the case of this, it's been machined from epoxy model board. It's necessary to use epoxy model board as opposed to polyurethane because the moulds that we're going to make are made from pre-preg, and pre-preg doesn't work with polyurethane. This has been machined on a 3-axis router. That's a machine that's got motion basically in 3 planes, so down the X, Y, and then the Z axis. Not necessarily a 5-axis machine. So actually most of these areas on the mould can be accessed just simply from a 3-axis point. A CNC machine will first of all go through and rough out the shape, and then it will continue on and do fine finishing passes. But if anybody's ever done this before, you'll be more than aware of the fact that it doesn't leave you with a finish like this. So what did it actually take to go from the machining through to this that we see now with a high gloss finish?
Well, we had to go through rounds of sanding and then sealing the board and then sanding again up to a final seal and polish. As you see, we left all the flanges. They only have 2 coats of sealer. And also all the inserts locate. They also have only 2 coats of sealer, so this will ensure that inserts and the 2 halves of the mold, they fit right. Yeah, because obviously with the sealer, as you put multiple coats of sealer down onto a pattern, it will build up a thickness. Now, the amount of thickness it builds up is, although very, very small, is acceptable on the moulded faces, but where you need the accuracy, where the moulds come together, the inserts go in, that any build-up on these areas would lead to inaccuracy on your flash line, so that the tools wouldn't fit together as well. But just looking at this, I can also see we've got an awful lot of holes machined into this. Yeah, we do have around 60 pins, which ensure that the 2 halves, they bolt together right. So it's for location for clamping purposes. Because carbon molds, they're not as stiff as solid block of aluminium. Yep. So that's why we need those clamping points. And the closer they are to the edge, the better. Okay. So these will have metal pins placed into the pattern, so when the mould's made, that'll be laminated around those, and we actually end up with holes in the mould itself. So all of that aids in just aligning everything perfectly and making sure that the mould is accurate and true. There's a few other sort of areas of interest that I can see here. We've got areas that don't look like they're part of the original bike. We've got these sections for the inserts. How do you determine where you need inserts? Well, everything that's an undercut, it requires an insert. And also some of the hard to laminate areas, they could come as inserts as well. Okay, so presumably like in this area here. Yeah, when the shock tunnel is, that's why we need an insert, but this is all extended because we need this insert to locate into the mold. And that bolts in using the same method as the molds come together. Okay, right, so from the pattern, we've gone through, we've put a sealer down onto it, then presumably multiple coats of release agent to ensure we get a good release. Likewise on the metal pins that drop into these holes, they'll need an awful lot of release agent because they've got to be drawn out from a completely parallel bore. And then it's on to making the mould itself. Here's the completed mould that's been taken from the pattern.
And this has been made from an X-Preg tooling pre-preg. So it's done out of autoclave, so just under vacuum in an oven. And the black surface finish that you see here actually comes from the pre-preg itself. It has a glass fibre scrim cloth that supports pigmented resin, which gives you really excellent tool surfaces. The actual layup of this itself, Vlad, how many plies of material do you have in this mould?
Well, it's pretty simple. It's one layer of the surface ply, and then we have another 5 backing layers, which are high weight.
Yeah, and so that builds up the main bulk of the mould.
This builds up and bulk it up and gives the strength to the mould.
Okay, I'm looking at this. It's obviously quite a complex shape that we're looking to form, and this pattern, obviously, that's not going to be laid up in just one piece of material, is it?
No, it can't be in one piece of material. I started with the corners, and all corners they go in plus minus 45.
So you actually cut the material, the surface ply, thin strips at 45 degrees.
Yeah, at 45 degrees. So this ensures that all the corners are pushed in. Same goes for every single pin. So we have little strips of 45 around every single pin.
Every single pin.
Yeah.
That must have taken quite some time to laminate.
Quite some time. And before finishing the first ply, this has all been debulked.
Okay. So so you debulk after what, between every ply, or?
I debulked on the first ply twice, when the corners were in and then when the corners were covered. So this ensures that the first ply stays on.
And that actually just helps to tack it down into
it helps
into
tack
the mold.
it down. And the second debulk was, I left it overnight. So this makes sure that when I come in the morning, it's all like properly stuck to the mold.
Fully consolidated.
Yeah.
So the purpose of a debulk are basically pulling a vacuum, usually with a perforated peel ply. You pull a vacuum and it just compresses at each stage of your lamination. It takes the bulk out of the material. So where the material's normally sort of sagging away from the mould, by putting it into a vacuum bag, it presses it into the corners and really ensures a good layup. So once it was all laid up, that's been cured. So it was done a low temperature initial cure.
Yeah, low temperature initial cure, which was slightly longer. Then it was taken off the tool after a good fight with all those pins.
Yes.
Yeah.
Extracting the pins from this, once they were, if you imagine the mold, the pins coming out of here through this section, they were completely parallel pins. So actually drawing them out is quite difficult. We opted for a trick of using a cordless drill to actually spin them out, and that worked reasonably. It did work quite well. So the reason for a low temperature cure, why not just take it right up to say 120 degrees and do the cure at that temperature, is that epoxy model board actually expands. All model boards do, and all materials expand at different rates. And if we went straight up to 120 degrees, this pattern would actually be larger than it was originally machined. So it's cured at a low temperature, it's then removed from the pattern and then post-cured, and that does the final hardening of the mould and makes it able to operate at its final service temperature.
Just to add on for the post-cure, we had both halves together bolted up because the flatness of the board is, even after it's machined, the board always have a little bow.
Okay, so it's not perfectly flat.
It's not perfectly flat. So in our case, the molds were the edges were warped up, and the center was a bit lower.
Mm-hmm.
But this was fixed by bolting up the two halves together.
Yep.
And post-curing them.
Right. So the final stage of the curing was actually done with the molds, bolted together, which will, when you do a post-cure, it slightly softens the resin, and when if they're bolted together and pulled flat, when it softens the resin, then it finally does its final cure and hardening, it will be much more accurate by putting the two together. So that's a great tip for anybody making pre-preg split tools.
And you're also not stressing the tools by trying to overcome the warp.
Every time you're clamping them up. If you do want more information on how to go from a machine pattern, prep it and make molds, we do actually have videos just specifically covering this topic in quite a lot of detail. So if you're interested, it might well be worth checking those out. We mentioned briefly when we were looking at the pattern that there's a lot of inserts in the frame. Now, these inserts are the sections for like where the shock comes through, the shock tunnel here. We actually have the frame splitting, so we need another piece of the mould that can then be drawn out. So I'm looking at these, Vlad. They're not made from the same material as the mould,
no.
And they're not made from model board. So tell me what these are all about and how you made them.
So basically, machine patterns from epoxy.
Okay.
Epoxy motherboard, and then I cast silicon over this motherboard.
You made a negative from silicon. Yeah.
Yes, and from this negative, I use high temperature resin and graphite. It's graphite powder.
So the graphite powder, okay.
To give it actually some strength. And I've casted the inserts into those silicon molds.
Right, so you just poured the resin into the silicon molds to actually make that insert. Forgive me for asking, but why not just machine an epoxy insert?
Well, again, as we mentioned earlier, epoxy expands under temperature.
Mm-hmm.
And we need something which is with similar expansion rate to the tool.
Because these tools are carbon fibre, and carbon fibre is well known for having very, very low rate of CT, so coefficient of thermal expansion, the amount it changes in size with heat. And epoxy motherboard, although it's quite stable, you're saying it's in these cases with a large insert like that, it would actually cause problems through its expansion.
Yeah, it might cause problems. So it's better to
have something
take it out of the equation and. Yeah.
Right. Okay. So these are graphite filled, high temperature epoxy inserts then.
Yeah, which you can see the difference between this one and this one. So this one, that's how it comes out of the mold.
Yeah.
Out of the silicon mold, and this one has been sealed, polished, and released. The inserts, they need to be polished, so they come out of the frame easier.
Okay, so
when it's demolded.
So in terms of the sealing and finishing, just the same as a mold. So an S120 board sealer,
yes,
and then easy release agent over the top of it.
Yes.
Okay.
That's it. Another reason why we're using silicon molds is in case we break an insert. And in prototyping, sometimes, mistakes happen. So this is just making sure that when we mold the frame, when we get the frame out, if the insert is stuck, we can destroy the insert but save the frame.
Right. So they're almost sacrificial.
Yeah, they're sacrificial.
Yeah.
And then we can just go and cast another insert. So, and that's it.
Okay. Right. Easy way to sort of keep making the insert section. So we've got those in the head tube there. They're leaving moulding space for the bearing journals.
Step one, bottom bracket goes in, and same for the lower linkage mount.
There we go. Yeah. Fantastic. Okay, well, I suppose what we need to get onto now is the really interesting bit and see what goes into a layup on a bike. So here we've got the pre-preg materials that are going to be used for the actual frame construction itself. We've got the Xpreg XC110 system here, which is an out of autoclave, so just under vacuum and in an oven. We've got a woven fabric, 210 gram, and then a 300 gram unidirectional. The individual pieces of material are cut size by hand and marked to make identifying the correct piece easier during layup. In volume production, this process would normally be performed by a CNC cutting machine. The majority of the unidirectional fabric's now been cut, and we've seen that that's been done oversized to allow a little bit of adjustment and alignment and actually tailoring it on the job. But this templating that you're doing here with the masking tape, why are you doing this at this stage?
Well, this is specifically for the first layer, which is not UD, it's going to be twill.
Okay.
And we're going for the raw carbon finish, so all the weave needs to be adjusted. So the frame is made in 5 or 6 separate pieces, and those pieces, they need to match together.
Right, so this is templating for the woven layer, the twill layer that's going on first, and you're using these templates to make sure that the weave is going to align accurately. And a lot of that will be presumably for cosmetic purposes to make sure that,
cosmetic purposes.
Yeah, because the frame is going to be left in that sort of natural raw carbon finish. So this is the complete kit of parts then. How many parts are there in this frame build?
Well, roughly we have around 300 individual pieces.
Wow.
Which go in both halves.
So 300 individual pieces. Right, I suppose now we've got the kit of components, it's time to see the layup itself. So these molds are all prepared with release agent and ready to laminate onto. So what's the first step, Vlad?
Well, the first step is actually to put the head tube piece and then start with the bottom tube, top tube, and join. So
this is working with the 200 gram woven fibre first and just systematically lay that down onto the moulds, and you're doing both of these simultaneously?
Yep, do both of them simultaneously, and also flipping it's mirrored, one side is mirrored to the other side.
I suppose it helps, it makes things a lot quicker if you're working on both molds at the same time, and you just do the same component on each one and then move your way between the two.
This way you end up with exactly the same amount of carbon in both halves.
Okay, right, let's see it done. The first ply into the mould is the layer that will be visible on the outside of the part. So when you are looking for a really good cosmetic finish, extra care should be taken with this ply to ensure that all of the weave is perfectly oriented, laminated and aligned. One side of the frame is trimmed down to the mould flange and the other will be left protruding to start the laps that join the frame halves. So now you've got the first ply fully laminated, you're choosing to do a debulk at this stage, is that right?
Yes, it always helps after the first layer. So with complicated parts like this, it just pushes all the corners down and gets the detail.
Right, so just, consolidating it into all these sharp features and details in the frame. Now that we've got the first ply laid up and debulked, what's the next stage?
Well, it's the second ply, which is again, we use 210 gram twill. But it's going to sit at plus minus 45 degrees.
Essentially just the same as this first layer, but we're using the same material, but turned around through 45 degrees, presumably just to give it more even strength throughout.
Yeah, it just strengthens the skin.
The second ply is laminated in just the same way as the first. The 45-degree orientation increases the torsional stiffness of the tube prior to the unidirectional plies that will follow. So we've got the first two plies into the mould. So we have the 090 woven fabric and then the plus minus 45 degree woven fabric after that. So the next layers to go in are unidirectional carbon. Now, unidirectional carbon has all of the fibres running in one direction, which means all of the strength, or nearly all of the strength, is running in that direction. So in the case of a bike frame, how do you take most advantage of unidirectional fibres?
So the basics are we run along the tubes. So this way we tie head tube to bottom bracket to all the mount points, like where the linkages go and where the shock go. Another use of the UD is actually around those same points to reinforce and to add extra strength.
In the case of a tube, you want the strength down the length of the tube, so we predominantly align the fibres down that way.
Yes.
And then maybe on mounting lugs, you would, where the loads are going in a different direction,
you wrap around.
You wrap it round to put the load through in whatever direction it's travelling in. Let's start laminating. As this frame already has good torsional strength and hoop strength provided by the woven surface plies, the unidirectional material is oriented straight down the length of the tubes. In the case of this build, the main tubes consist of 2 plies of 210 gram 2-2 twill on the surface, followed by 4 plies of 300 gram unidirectional, and finally backed with a further 1 ply of 210 gram 2-2 twill. This laminate is overspecified for the build and will almost certainly be reduced by 2 or 3 plies after this first proof of concept has been tested. Stressed areas such as the head tube, suspension mountings and bottom bracket will have more plies that stagger into the main tubes, forming a taper to spread the stress concentration. So with the layup almost complete, this is a great opportunity to go around having a look at how Vlad's tackled some of the more complicated or challenging areas of the frame. So the first and most obvious thing are the laps. We can see here these are not just a straight lap, they are actually staggered. Could you explain why you've done it this way and why it's the best way for a bike frame?
Well, this way we, by having all the layers exposed of the twill, we make sure that everything is connected from this half to the other half.
Okay.
And on the plus side, we have all the UD, let's say, for example, between first and second layer of the twill that you see. You have UD encapsulated in.
Right, so what looks like just twill at this point is actually has actually got UD buried inside there as well.
Yeah, further down, below the edge.
And so on the counterpart from this staggered lap, we've got the same thing staggering in reverse here. And so I suppose the theory is that these laps and the staggered sections here,
yeah, they match the other half.
Match the other half.
And this way we have much more constant thickness in the laminate.
Yeah, so keeping a relatively uniform wall thickness throughout the tube. Okay, so other areas, I mean, certainly let's take a look around like the shock mount here. This is another area of the frame. It's not just a straight tube, it's highly stressed. Could you go through the process of achieving a good result in components and areas of the frame like this?
So basically, we can see only the top layer here, but underneath the top layer we have unidirectional carbon going around the pin. The reason why I laminate around the pin is because, for example, if you drill the hole, then we have fibers which are just
have been broken effectively by the drill bit.
So now all the fibers, they do what they're supposed to do.
This area is completely solid with carbon, so there's not going to be any vacuum bag in there. Presumably it's really critical, the number of layers that you put in that area. So looking at the head tube, I can see we've got inserts in a very similar way than we had around the shock mount here. But it does look a little bit more complicated. So could you run through what the layup is around here and what the main considerations are? So
basically, again under the twill we have loads of UD wrapped around the bearing cups.
Okay, so yeah, unidirectional, spiraled around there, because effectively that's where your steerer tube goes through, your bearings are sat into the frame there, and this is under huge amount of strain coming up through from the forks. So that hoop strength that you get from the UD is absolutely key in that area. And then we've got the laps at the front here, just like we have around the rest of the frame.
We do have the laps which lock the top and the bottom of the head tube and the front of the head tube. But again, we have the UD here also connects to the other half. Because we don't have any laps here, the function of those two hoops, they have to keep the two halves together in this area. Exactly.
Right, so this area here actually becomes almost like a bonding face that mates to the other side. And because the vacuum bag can't get into that corner there, again, this must be very critical on laminate thickness to make sure you get good consolidation between the two.
Again, it relies, like in the shock mount, it relies entirely on how much carbon is in there.
Right, so purely on the compression provided by the tooling. Okay. Next section we're going to look at here is this part of the frame here. Now this is actually the shock tunnel, so it's where the frame wraps around the rear shock unit. This isn't a straightforward compression fitting like that. It does have the vacuum bag as well, so could you explain how this one works?
Well, we have a combination of bag and compression area.
Okay, so towards the rear here it's very much the same as...
Yeah, so where the dropout for the linkage is mounted, the insert actually presses down.
That provides a consolidation
all
there.
The carbon
just the same as here.
Yes, exactly.
And then this section here, presumably these now will need laminating.
Yeah, they do need laminating, but the reason why they're not laminated, because I had to check again like a few times if the compression model area is alright and if the laps actually open correctly, and we don't want them overlapping on each other.
So where the linkage mount is there, that's a solid laminate in there, very much the same as around the actual shock mount here. And then this section here will have a vacuum bag pass through it.
Yeah.
Okay. So presumably now the next stage is to just laminate the material onto the inside of these to effectively close that and turn it into a short but squat tube. We now have all of the carbon fibre laid up into the frame, so we're going to be moving on to the vacuum bagging stage. Now, it's a lot more common, you'll see in mass production, to use an inflatable bladder, which is done in billet aluminium tools, closed together and pressurised. However, for prototyping and small volume production, it's perfectly viable to use a vacuum bagging technique. Now, it's a bit strange to think that a vacuum can be used to apply pressure onto the inside of a tube, but hopefully this will show you how it's done. So what's the first stage in this process, Vlad?
Basically, it's cutting the bags to size.
Okay, so the vacuum bagging tube, cutting that and then
we need to seal them there.
Sealing the ends. Okay, let's get going. So now with the vacuum bags made and sealed, they're ready to go into the mould. But before that, I understand you're going to put some release film down, and that's there to stop the bag from gripping onto the surface.
Yeah, we did put some release film down just on the half where the laps are. It's basically will allow the bag to slide and position itself into the mould. So when we apply the vacuum.
With the pre-preg being quite tacky on the surface, you've got the vacuum bag. If you imagine having a bit of pressure against that, it's very difficult for it to slide and move out into the frame. So if we use some release film, that then lets the bag sit in and slide around. The real thing to be careful of here is that you don't get any release film going onto the wrong side of your lap. If you get a bit of release film between the lap and the other side of the frame, you're going to have no bond strength whatsoever, and that could be a potentially very dangerous situation to be in. So the release film is just going into this one side on the side with the laps, and then there's no risk of it subsequently getting into the gap. So the first bag is going to be the one on one side of the shock tunnel here.
Yeah, that's correct, and then we close the insert.
So it's very important to make sure that all of these laps don't get trapped underneath the edges there. This is the 4 bags in the mould. So each one of these is sealed at the end, so it's not a continuous tube. So we've got one bag that comes in through the head tube, along the top tube, and meets here at the seat tube. And we can see that pairs against the bag that's here. We've got this seat tube bag on this component and on the other side. So we've got 2 bags going in through that same aperture in the seat tube, and then they pair off either side of the shock tunnel, and again they're sealed off at the end here and meet the 4th bag, which is this one on the down tube, which comes out of the bottom of the steerer tube. So I'm noticing here you've got an awful lot of creases and wrinkles in the bag. Why is it important to have this much extra? The
profile of the tubes, it tapers out, so even though the diameter of the bag is enough to cover, it's good to double up in areas like this. And same for the bottom bracket. You can do it this way, or you can go like this way. It's as long as you have full coverage of the area. Yeah. Yeah, and as long as there's enough bag to push the laps out, that's job done.
And so why is this not just done with one sort of continuous bag? Why have you got 4 individual ones?
Well, it could be done with one bag, but then if you want to remove the bag, in this case we want to remove the bags, it just makes it easy to pull them out separately, so this way they won't be locking anywhere.
Right, so after curing, yeah, you're just pulling out one continuous bag rather than a hoop that would be, you'd have to tear.
Yeah, also that's one of the reasons why we put also the surface film on.
Oh, to make
just to make them slide easier.
At the end easier. Yeah. Okay, so the next stage now is to close this up. This is pretty high stakes, so presumably it's just like we did with the shock tunnel inserts, making sure everything's folded in neatly, that you get no material trapped on these barriers. We've got the moulds just held slightly open. Obviously we tried to get all of those laps to fold in as best as we could, but actually to make absolutely certain that they're down, we can gradually close the mould and go in through the gap and just push the laps in to make sure that they never get pinched between the 2 clamping faces. For these bolts that are clamping the moulds together, I noticed that this is a 6mm bolt that's actually going through an 8mm hole. That won't help any when in the alignment, so what are you using to make sure that these moulds are sitting perfectly and accurately aligned?
So the first thing that actually aligns the front of the mould is the inserts.
So the inserts themselves.
The head tube inserts, But because we don't have any inserts aligning the mould at the back, we have few of those pins, we just use them as location pins. So we just get a 8mm pin and this goes in. So this makes sure it's located. Yeah, and put a couple more on the back, and the rest is just...
And so all of these bolts are just there to clamp the mould faces. So these 4 inner bags are now projecting out of the clamped up mould, and this whole assembly now goes inside another vacuum bag that will surround it, and the inner bags will come through the outside of the bag. Hopefully this will make a bit more sense when you actually see it. So essentially, all we're trying to do with the inner bag is breach the seal of the outer bag. So we've got the seal to the outer bag, the pink bag here. So we draw the seal back, tack the inner bag across the sealant tape, then seal over the top of that bag with another section of tape, which then allows the outer bag to fully seal around it. So now in this section here, we actually have a breach through the seal, meaning that the ambient atmospheric pressure, when we draw a vacuum on the main bag, the atmospheric pressure is not sealed to this inner bag, and so that will inflate with atmospheric pressure. So it's all bagged up now, so this is basically ready for a cure, but before that we're going to do a bit of a debulk. How long are you going to leave this under vacuum?
Well, we're going to leave this overnight and put it in the oven tomorrow morning.
Debulk overnight, that gives us opportunity to make sure that the bag's holding a perfect seal and gives extra time for the laminate to fully consolidate. So we've left this under vacuum debulking overnight, and so now all that's left is the final cure. For this cure, we're using the XPreg XC110 extended cure cycle, which is a two-step cure cycle with a final cure temperature of 120 degrees C. Full details of the recommended cure cycles can be found on the XPreg XC110 technical and processing datasheets on the Easy Composites website. So this is the frame exactly as it comes out of the mould. So it'll be a great chance for us to take a look, see how the inserts work and see the standard of finish that's been achieved. First thing, Vlad, we've got these inserts and they make a lot more sense now. I can see them integrated into the frame. So removal process for those, what's involved?
Well, it's pretty simple, just knocking them out of place.
Okay.
And with the draft angles positioned correctly, we should be able to do this with not much trouble.
Okay. Oh, yeah, that was a lot easier than I would have anticipated. And then,
the big ones,
yeah, let's get those out. So all the inserts are out. That is essentially the final frame prior to finishing. So looking at this, you can see we've got quite a bit of flash. There's the occasional bit where the odd fibre has come out into the flash line. That's what you're trying to avoid when you close the mould. But as long as you only get very slight bits, single fibres, they will get clamped into the mould and won't cause a problem. So if we get up really closely to this top tube section here, you can see the end result that we've managed to achieve straight from the mould. Now, there are some very, very small surface pinholes here. This would be typical on a part like this that's got multiple plies. The vacuum bagging's inaccessible during the processing. But these are very insignificant. They don't really have any structural bearing on the part. And as soon as this has had the paint or the clear coat, these will become completely invisible. So it's just a good opportunity to show you the great results that you do get straight from the mould with the XC110 system. So with the front triangle moulding complete, what's next from here?
Well, repeat the exactly same process for the rear triangle.
So this is the rear triangle sections all laid up and ready to vacuum bag. On the face of it here, it looks very similar to the front triangle. Is there anything in particular that's different about this?
Well, you're right, it's more or less the same. The difference comes in the structure. Most of the UD is on the outside of the tubes, and the inside we have less material because we have those laps closing on.
So this section that will close to this is laminated thinner, and then these laps here will give that area more bulk.
Yeah. Well, the laminate is going to be even inside, outside this way.
Okay, well, let's press on and do the vacuum bagging. Same as the front triangle, these are going to go into an envelope bag, and these internal bags are going to come through the seal on the outer bag, putting the vacuum onto the inside of the tube. So this will be cured on the same cure cycle as the front triangle. So we're going to pop that in now, and we'll see you in a few hours' time for the demoulding. Okay. So the two sections of the rear triangle out of the mould, what's the next stage from here, Vlad?
Well, same as the front triangle, we need to give them a good clean and deburr, and then we need to prep them for bonding.
With the rear triangle now deburred and trimmed and prepped ready for bonding, it's now just a case of aligning those two parts together. So I see here you've got the two sides of the frame, so you've got the front triangle and the linkages. Why are we using this rather than a full-blown jig?
Well, we're using this because it's the first prototype, and because everything is molded on the front triangle, it gives us pretty good alignment for the rear. Okay,
so it's just a case of presumably taking those two elements, using a structural adhesive in between the two, and then aligning it all up. Yeah. Right. To prepare these parts for bonding, the mating faces were degreased and abraded with 80 grit sandpaper. There is approximately a 0.5mm gap, which allows for an effective bond line and will allow a small degree of adjustment and for final alignment. The adhesive we're using here is the Voodoo Glue VM100 methyl methacrylate adhesive, which is an excellent choice in most composite bonding applications. We have plans to do a video dedicated to comparing and testing adhesives. If you want to hear about this when it's released, please subscribe to our channel and hit the notification bell. With the front and rear triangle now essentially complete, or at least all the composite side of things are, what's the next stage from here to take this to the finished article?
Well, next stage is a little bit more sanding. So I'm going with a satin clear coat, and I'm going to keep the raw look of the carbon frame.
Right, so you're keeping the raw carbon finish with the satin clear coat. Right, well, next stop, the spray booth. So this is it. These are the completed frame components back from paint. So from a composites perspective, all the work's now done. What are the next steps for this?
Well, we need to assemble it. So put the linkages in, put the shock, and then put the rest of the components. And yeah, the plan is that this is going to be raced this weekend.
Right, so it's going straight out this weekend, yes, and see how it does.
We're only going to have like 1 day of testing before the race, and that's it.
Right, okay, well, if you're racing it this weekend, I think we should get the GoPro out, and hopefully, if all goes to plan, the next shots you'll see of this bike on the track. I hope you've enjoyed following us along through this project. To support our channel, we always appreciate a like and subscribe. If you're feeling inspired and want to learn more about composites, please check out our other videos where you'll find more detailed explanations of the various processes and techniques that you've seen used here. And of course, you can find more information on the materials and equipment used in this project on the Easy Composites website.